Hello, friends. Welcome to Astonic Chem Academy. And today we're looking at 10 most repeated topics in chemistry. So, what are the topics that are mostly repeated in UTME? So, the topics are number 1, organic chemistry, number 2, stoichiometry, number 3, electrolysis, number 4, gas law, 5, acid, base, and salt, 6, periodic table, chemical bonding, redox reaction, inorganic chemistry, atomic structure. If you are a chemist and a tutor of chemistry, you realize that these topics are mostly repeated in chemistry. These topics are carefully selected based on the analysis of past JAM UTME questions. Okay, you see them, they are rated very, very, very bad. In this video, we'll look at the most repeated topics in chemistry, UTME. We look at a step-by-step details explanation on the said topics, and at the same time, look at additional details or deep revelation secret on the topics and method and approach to questions within the time frame of your JAM exam. My name is Ayodele Kazum. I'm going to be your tutor for this. Let's quickly dive right in. If you are yet to subscribe to this channel, please do well to quickly subscribe now. Question number 1. How many isomers of C4H9OH will be tertiary alkanol? So let's quickly draw the structural formula. Carbon catenating with another carbon. We have 4 carbon. Then join with OH. Then we have hydrogen connected, hydrogen connected, hydrogen connected, hydrogen connected, hydrogen connected. So this one we have this is what we call primary alkanol. All right. Now looking at this, draw it in another way. We can have 1, 2, 3, 4. We have hydrogen, hydrogen, hydrogen. We have OH. We have hydrogen. We have hydrogen. We have hydrogen, 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 and hydrogen. This is secondary alkanol. Now let's draw the third one here. Carbon connecting with carbon, connecting with OH, CH3, CH3, CH3. This is tertiary alkanol. In other words, our correct answer is option A. So we only have 1 isomer that is connected to this. So a quick revision on alkanol. We have 3 types of alkanol. We have primary, secondary, and tertiary. This is a primary alkanol. This is a secondary alkanol. And this is a tertiary alkanol. How do you remember? Here we have carbon that is connected to OH is what matters. See, this carbon is connected to this OH. What are the connecting agents? 2 hydrogen, 1 hydrogen here, another hydrogen here, and 1 R. Let's go to this one. This is the carbon connecting with what? With OH. So we have 1 R, 1 hydrogen, and 1 R. Here, this is the carbon connected with what? OH. So we have R, R, R. In other words, under primary, we can have something of this nature. Under primary, we can have C, O, H, H, R, H. Under secondary, we can have C, O, H, R, H, R. While under tertiary, we can have carbon, O, H, R, R, and R. In other words, when you are dealing with alkanol, in terms of primary, secondary, and tertiary, what is important is the carbon that is connected with the OH. So if around it you have 2 hydrogen and 1 R is primary, around it you have 1 hydrogen around that carbon, 2 are key is secondary. For tertiary, you have around the carbon we have 3 R. That's what? That's tertiary. Now let me quickly remind of something important in organic under isomers. We quickly need it. How do I get my isomer, especially for king? Let's look at king series. Let's look at isomer. You can use this formula, especially for JAM student. You can use this formula that says 2 raised to power n minus 4 plus 1. Where your n range from 4 to 7. 2n minus 4 plus 2. This is when n equals to 8. You can use n minus 4, n equals to 3. That's when n equals to 9. Question number 2. Which of the following produces effervescence with sodium hydrogen carbonate. That's UTME question 2024 question number 1. So we have ethanoic acid, we have ethane, we have bromine water, propane. So let's look at the one that produces effervescence. That's giving out CO2 gas with sodium hydrogen carbonate. The formula for sodium hydrogen carbonate is NaHCO3 plus. Let's start with this. This is an acid. So because of the presence of this also carbonate, okay, carbon dioxide will definitely we produce. So we are to produce CH3 COONA plus H2O plus CO2 gas. This question number 3 is a stoichiometry question. It's a UTME exam. So let's look at UTME 2019 question 9. It's a stoichiometry question that says tin burning oxygen to give us carbon dioxide and H2O. So from the reaction above, what mole of CO2 will be produced from what? From 56 grams of tin. Let's bring out our equation. We have our equation to be C2H4 plus 3O2 to produce 2 moles of carbon dioxide plus 2 molecules of water. He has to calculate the moles of carbon dioxide. My relationship is stoichiometry between what? Tin and carbon dioxide. So what is stoichiometry? Stoichiometry is the relationship between a reactant and a product in a balanced chemical equation. In terms of what is called mass, can be mass based. In terms of volume, can be volume based. In terms of mole, can be mole based. And in terms of Avogadros. Avogadros. So these are what stoichiometry is all about. So in this particular question, our concern is ethene and carbon dioxide. What are we concerned under ethene? We are concerned about the mass. So let's calculate what mass of this one is. Carbon is 12 times 2 multiplied by hydrogen is 1 times what? Times 4. So when we do that, what I'm going to have? We'll have 24 plus 4. That gives us 28 grams of C2H4. C2H4 will produce how many moles can we see? And how many moles? We can see 2 moles. So we say 2 moles of CO2 because we are relating mass and mole. The given value, here, look at the given value here. We are giving 56 grams of ethene. So we have 56 grams of ethene giving us what? X. So when we cross multiply this, when we cross multiply, we are going to have 56 multiplied by 2 divided by 28. 56 times 2 giving you 112. 112 divided by 28. That will be around 4 moles. So your answer is 4 moles. So the correct answer here is what? Is option A. Remember, when you are calculating stoichiometry, you must be able to relate this. So other formula under stoichiometry includes, remember, you can have N is equal to mass over molar mass. This is a formula method under stoichiometry, which is also mole ratio. You can also have number of mole equals to V over 22.4 dm cube. At the same time, you can also have number of mole equals to CV over 1000. And lastly, you can also have number of mole equals to number of particles over Avogadro constant. And these particles can be in form of ion and can be in form of molecule, or it can be in form of atom. Question number 4, also a UTME question. I say, calculate the volume of oxygen measured at STP produced when 24.5 grams of potassium trioxochloride is totally decomposed by what? By heat. So the first thing is to write your balanced chemical equation. So we have the decomposition of K. Now, I told you in stoichiometry, we have to first of all identify what parameters are we working with. We have to calculate oxygen, all right? So we are looking for the oxygen and giving the value of what? So potassium trioxochloride. And the next question you ask yourself in this relationship is, in this oxygen gas, I have mole, I have mass, I have volume, and I have Avogadros. Which one in particular is the question referring to? So let's look at it. We are referring to volume. For this one, which question is it referring to? We are referring to mass. So it makes this question a mass volume type of relationship. So let's quickly calculate what the mass looks like. So we have 2 molecules here. So potassium is 39, plus chlorine is 35.5, plus oxygen is 16 multiplied by 3. So when you have that, you're going to have 39 plus 35.5 plus 48. When you have, 2 multiplied by 1, so you're going to have 39 plus 35.5 plus 48. You have 125. 122.5 multiplied by 2, you have 245 grams. That is the mass of KClO3. This mass now produce how many volume? So let's check the volume of the oxygen we have here. Let's check the volume of oxygen. Remember this formula that say N is equal to V over 22.4. So let's do that formula. Let's find our V. So we are going to have 3 multiplied by what? 22.4 dmq. So if you do that by cross multiplying, you are going to have 3 multiplied by 22.4, 67.2, 67.2 dmq. Now, from this, we can realize, we can see vividly now that 2245 grams of KClO3 produces 67.2 dmq of oxygen. Now, the question is, what will 24.5 grams now produce? To produce X, then what do? You cross multiply. When you do that, you have 24.5 multiplied by 67.2 divided by 245. The answer will give you 6.72 dmq of what? Of oxygen gas. So let's quickly check what the answer. So the answer is also A. Can you see? Did you get that before me? Did you get that before me? Quickly look at it. Question number 5 is on electrolysis. Okay. And it's 2023 UTME question 8. Calculate the volume in dmq of oxygen evolved at STP when a current of 5 ampere is passed through acidified water for 772 seconds. Molar volume of gas at STP is 22.4 dmq. Let's use this formula. This formula will be very helpful. So we have V over 22.4 dmq equals to IT over CF. Let's look at the parameter we have. V, that's the value we are looking for. Your I from the question, I is given to be 5 ampere. Your time, which is seconds, 772 seconds. Our Faraday is constant. F means Faraday 96500 coulombs, and our charge is going to be 4. Next question is, how did he get 4? The oxygen valve at the anode in this reaction, we have this ionization. Follow, you have oxygen 2 minus, giving us oxygen gas plus E minus. So you balance that reaction. 2 molecules of oxygen, 2 molecules of oxygen, 4 are electrons and 4 electrons. That's why we have 4 charge. That's why we have 4 charge there. So be that as it may, let's look at how we can substitute respectively and calculate what we need to calculate. So we have 4. So we have V over 22.4 dmq over our I is 5 multiplied by our time is 772 seconds divided by 4 multiplied by 96500. The next thing to do is to cross multiply and make V the subject of formula by having 22.4 multiplied by 5 times 772 divided by 4 times 96500 column. So our V will become 86464 divided by 38600. So use your calculator and get the same value. So when you divide these two, 86464 divided by 38600, your answer will be 0.224 dmq. So if you go back to the question, see that our answer will what? Option B. That's correct. Let me help you Jambite with some formula that will help you on the D-day of your exam. Formula like Q equals to IT. Formula like N equals to M over MM. Formula like M over MM equals to IT over CF. Formula like M over MM equals to Q over CF. Formula like V over 22.4 dmq equals to M over MM. Formula like M1 C1 over MM1 equals to M2C2 over MM2. So this formula basically will help you to quickly beat the timing for your calculation on the degree. I wish you good luck. Hope you got that before I do. Let's look at question number 6. You can see the question here. That's UTME 2024, question 33. In electrolysis of dilute H2SO4, the gas produced at the anode is. So what's the gas produced at the anode? Let's quickly discover the gas produced at the anode. Electrolysis of dilute H2SO4, we have H2SO4 and we have water. So this electrolysis H2SO4 will produce hydrogen gas plus SO4 2 minus. This one will produce hydrogen gas again plus hydroxide. Now, when you realize this will migrate, because they are negative, they will migrate to the positive we call anode, while the positive will migrate to the negative we call cathode. So at the cathode, we are going to have hydrogen gas being liberated. It cannot be hydrogen. So let's see what happens at the anode. So we have OH giving OH plus E minus. OH plus another OH will produce H2O, oxygen, and oxygen will pair up to give O2. Now, the aim of this particular reaction is to be able to produce water and oxygen gas. So let's look at our OH minus producing what? H2O plus O2 plus electron. So we balance the equation. We have 4 electrons and we have 4 this, and we have 2 molecules of what? Of water. So the gas that is produced at the anode is oxygen gas. So our answer is going to be what? Is going to be C. Did you get that before me? I guess you got that before me. The next question is gas laws. And this came from that UTME 2023, question 13. What are the laws that form the general equation? The laws that form the general equation is Boyle's law and Charles law. So the correct option is what? A equals to P2 V2. By Charles law, talk about V1 over T1 equals to V2 all over T2. These two laws combine together to form general gas equation, which is P1 V1 over T1 equals to P2 V2 over T2. V is inversely proportional to P. So K is equal to PV. Why? From Charles law, V is directly proportional to T. In other words, K is equal to V over T. So in that way, we're going to have K to give us PV over T, which gives us the general gas equation. Let's quickly move to the next question. This question number 8, still on gas law, is from UTME 2024. At STP, a mole of chlorine occupies 22.4. Okay, that means at STP, we're talking about STP. That means I'm talking about my P1. Sorry, at STP, I'm talking about my P1 and my T1. My P1 at STP is 760 mmHg, and my T1 is going to be 273 Kelvin. Okay, occupies, that's my V1, 22.4 dmQ. All right. If the temperature changes, that means now my temperature has changed from, I'm going to have, instead of 273, I have my T2 to be 35 degrees Celsius. Of course, I'm going to change it to Kelvin to 73. That's giving me what? 308 Kelvin. All right. And my pressure, that's P2, will give me what? 750 mmHg. So my V2 is unknown. This question is a general gas equation that I can use. I can use P1, V1, T1 equals to P2, P2, T2. Let's substitute. Our P1 is what? 760 multiplied by 22.4 all over. My T1 is 273. My P2 is 750 multiplied by my V2, that's my unknown, and my T2 is 308. So the next thing for me is to make my V2 subject of formula. I can have my V2 to be 760 multiplied by 22.4 multiplied by 308 divided by 273 multiplied by 750. So let me get my calculator and quickly get 760. I have 760 multiplied by 22.4 multiplied by 308, which give me 5. That gave me 5, 2, 4, 3, 392 over Let's quickly check. I have 273 multiplied by 750. What do I have? I have 204750. So my final answer will be 5243392 divided by 204750. So my answer is 25.6. I have what? 25.6 DMQ. So let's check if we have such answer for my question. The correct option there is option B, 25.61. Is that correct? Good. Question number 9 is acid, base, and salt. That's taken from question 31, 2024 UTME. Determine the pH of H2SO4 whose concentration is 0.001 molar. So this is pH calculation. So before I'll solve, let me quickly remind us of the formula that we can use under pH calculation. So let's say pH calculation. pH calculations, number one formula that is very useful. You have pH equals to minus log hydrogen ion concentration. Number two formula, POH equals to minus log hydroxy ion concentration. So this hydrogen is for acid, this one is for base. Number three formula we can use pH plus POH can give us 14. Okay, if you check your pH range. Number four, you can have H hydrogen ion concentration multiplied by hydroxy ion concentration give us 10 raised to the power minus 14. These are the formula we can use to calculate. So the formula we're going to start with is this. But before that, let's analyze what we have. We are given an acid. The acid you are giving is H2SO4. And we have to calculate the pOH. That's for base. So let's ionize this one. You have this H plus SO4 minus. So the concentration here is 0.001 molar. We are going to multiply it by what? By 2 because of there are two hydrogen ion. So we have 0.002 molar of H plus. So the first thing for us to do is to get the pH. Then we'll use number 3 equation to solve the problem. So our pH equals to minus log what? H plus. So let's start with that. So remember, substitute minus log, you have 0.002. So for you writing jam is base 10, you have just quickly take it to what? Take it to standard form. 1, 2, 3. That giving me what? Minus log 10 base 2 times 10 raised to power minus 3. Did you get that? Remember your law of indices. Okay? Logarithm law, indices law, all of them are applicable. So we have minus log 10 base 2 plus minus log 10 minus 3. Recall that in logarithm we have log of the same base. Log A base A will give you 1. Log A base A will give you 1. At the same time, log A base A raised to power B will give you B log A, which will actually give you B times 1 equals to B. So let's apply the same thing here. So I have minus log 2 base 10 rather. Okay, this one will come like this. We have plus minus 3 bracket minus log 10 base 10. Remember, I said log of the same base equals to 1. So I'm going to have minus log 2 is 0.3010. Remember to master some of this log. You have minus times minus, that's what? That's plus. If there is minus here, minus times minus, that's plus. So we have plus 3 times 1 because these two will actually give us 1 according to the rule. What do we have now? We have minus 0.3010 plus 3. So giving us 2.699. Remember, this is our pH now. So if you now use formula 3, formula 3 says pH plus POH equals to 14. So my pH is 2.699 plus POH equals to 14. So my POH will give me 14 minus 2.699. So my POH will give me 11.3. Okay, let's quickly check whether we have 11.3 in the question. Yes, correct. Our answer is A. Did you get that before me? Did you get that before me? Quickly check whether you got that before me. Question number 10 is still under acid, base, and salt. So the basicity of CO3 is what? Then you want to remind yourself what is basicity? The number of replaceable hydrogen and one molecule of an atom. So if you have this CA3, COOH, it can ionize in this manner: CH3 COO minus plus H plus. So out of the 4 hydrogen inside the ethanoic acid, which of the hydrogen is replaceable, and how many of the hydrogen are replaced? Is the last hydrogen that ionized? This hydrogen is replaceable, and it's only 1 hydrogen that is replaceable, and that makes our answer to be 1, which is option A. Question 11 is on periodic table. That's taken from UTME 2023, question number 1. Which of the following exhibits the most electronegative character? All right, let's quickly analyze them. Aluminium is 13, that's 2, 8, 3. Silicon is 14, that's 2, 8, 4. Phosphorus is 15, that's 2, 8, 5. And sulfur is 16, that's 2, 8, 6. So when they say most electronegative, which one will attract electronegative ion quickly? Of course, this share, this third share, the maximum number of this third share is 8. And so the possibility of sulfur getting 2 electrons to be attracted by 2 electrons is very, very high than any other element. So the correct answer is going to be what? Sulfur. D. Okay. And when you check the electronegativity character number, you know, sulfur is high, around 2.5, something thereabout. Question number 12 is also on periodic table. That's taken for UTME 2012. Group 7 elements are what? Group 7, are they monoatomic? Are they good oxidizing agents? Are they highly positive? Are they electron donor? So let's quickly check what they are. So group 7 elements are chlorine, bromine, in that order. This is 7, 17. That's 2, 7, and 2, 8, 7. Group 7 elements are elements that have 7 at their outermost shell. So which one are they? Are they monoatomic? No, they are diatomic because they are written as F2. Are they monoatomic? No, they are diatomic. You write them as F2, Cl2, Cl2. Are they good oxidizing agents? Yes, they are good oxidizing agents. Are they highly electropositive? No, they are highly electronegative. Are they electron donor? No, they don't donate electrons, they accept electrons. Question 13 is on bonding. Call it chemical bonding. Say the bond formed between water and hydrogen ion to form hydrozonium ion is what? What type of bond is that? The bond formed between this is called dative bonding. What is dative bonding? Dative bonding is a type of coordinate covalent bonding. In covalent bonding, they share electrons equally. But when it comes to dative bonding or coordinate covalent bonding, they don't share electrons equally. Only one of the participants, which is water, here bundles the electrons and share 2 for hydrogen ion to be used. Can I explain that quickly? Let me quickly explain that. Now we have water and hydrogen ion giving us hydrozonium ion. Let me explain what happened here. Water here, oxygen. Oxygen here have 8 electrons. So we have something like this. Oxygen. So look at what happened. That's 2, 6. Then we have another one. 1, 2, 3, 4, 5, 6. That's for oxygen. Now hydrogen have 1 electron. Remember we have 2 hydrogen. So 1 hydrogen will come to this side. I use dots as hydrogen, electron coming from hydrogen. This hydrogen. Okay, another hydrogen this side. I use dot as electron coming from hydrogen, another hydrogen. This is H2O plus. In addition with our hydrogen. This hydrogen does not have any electron around it. So and it needs to bond to this particular. We will come and use a lone pair. We have 2 lone pair, 1, 1. So oxygen have 2 lone pair electrons. So we will come and connect, or come and bond. Let me use the word come and bond with the free electrons of the hydrogen to form hydrozonium ion. So though our product will be like this: 1, 1, 1, 1. So just check what I'm drawing. So when you look at it very well, this is hydrozonium ion. Note that the electron that stars, they are from what? From oxygen. From oxygen. While the electrons that are dots are from hydrogen gas. Question number 14. UTME 2024. Question 22. Which of the following bond types involve transfer of electrons? The bond that involves transfer of electrons is called ionic bonding. So it's transferring from metallic to non-metallic. Example of such bond, you can have sodium chloride. Sodium is 11, while chlorine is 17. So sodium has 281, chlorine has 287. So there can be a transfer of electron from a metal, which is sodium, positive, to non-metal, which is called chlorine, is negative. So this sodium becomes 2,8, while chlorine also becomes 2,8,8. So sodium has obtained octet, while chlorine also obtained octet. Question 15 is on redox. Redox is one of the questions that comes out. So 2024-36 at UTME. Which of the following reaction is a redox reaction? Reduction, oxidation. That's the meaning of redox, in case you don't know. So the first equation, this is a neutralization reaction. This is a base and acid. This is Mg and oxygen. And in redox, there you have reduction oxidation. So the correct answer is what? Is B. This is a double decomposition reaction, and this is a decomposition reaction. So let's analyze this. So here, magnesium, oxygen was added to magnesium. So from here to here, we call it oxidation because oxygen has been added. And here to here, we call it reduction because oxygen has been removed. So let me quickly do a quick summary on the definitions on oxidation and reduction because you need it. Oxidation, then reduction. Number one, oxidation, addition of oxygen. So this one will have what? Removal of oxygen. Did you get that? Number two, removal of hydrogen. Number two of this one is what? Addition of hydrogen. All the definition, you need to learn it. Number three, say loss of electrons. You have gain of electrons. Number four, increase in oxidation number. Number four, we have a decrease in oxidation number. And number five, addition of electronegative elements. Why this one gives us removal of electronegative. Question 16. UTME 2024, question 7. Rust on the surface of a metal sheet contains what? We all know that rust cannot take place without presence of what? Of moisture and air. And rust is the oxidation of iron 2 to iron 3. Rust is the oxidation of iron 2 to iron 3. So the answer here will be what? Hydrated iron 3 oxide. Can you see there? So what we are saying now, we are going to have Fe2O3 dots XH2O. That's hydrated iron 3. We don't know actually what the addition salt is. So I represent it by what? By S. But just take note that anytime rust takes place, it must be in presence of moisture and water. Question 17 is on inorganic. So the chemical formula for laughing gas is, as a gas in chemistry that we use to call laughing gas. And the formula is N2O, nitrogen 1 oxide. Question number 18 is also on inorganic and is also from UTME 2024. So the following gases can be collected by the method of downward delivery. Okay, the best option here or the answer is chlorine. Chlorine can be collected by what? By downward delivery and is soluble in water. If you want me to do a video on whether upward delivery, downward delivery, just comment inorganic in the comment section and I will do a video on that. Question 19 is on atomic structure. Okay, so the number of unpaired electron in a ground state nitrogen atom is coming from UTME 2024 question 37. We can see there. So how do you do with nitrogen atom? That's 7. This is normally the atomic, but they're giving us is not a gas, now it's an atom. So you have 7, which is 1 x2 2p3. 2 plus 2 plus 3, that's 7. So how do we know if it's on the number of unpaired electrons? So let's check out. We have this suborbital, yes, this. Then we have 3 suborbital in p level. That's 1. According to Ohm's rule, they enter the orbital singly. So this is a pair. This is pair. How many unpaired? 1, 2, 3. So for nitrogen, number of unpaired electrons is 3. Question number 20 is also on atomic structure. That's taken from UTME 2001. Particle that contains 9 protons, 10 neutrons, and 10 electrons is positive ion, neutral atom of metal or non-metal, and negative ion. The correct answer is a negative ion. How do you know? When you see an element that have, say for instance, the element is fluorine, okay, which is atomic number 9. That's minus. Anytime you see minus in an element, it means it has gained an electron. So that's 9 plus 1 equals to 10, which makes the number of electrons to be what? To be 10. For neutron that is 19. That's going to be P plus N equals to A. Remember this formula? Okay. Our P here is 9. Our N is unknown. And our A is the atomic mass 19. That's 19 minus 9 equals to 10. So N equals to 10. That's a number of neutrons. That's why we have that to be 10. Thank you for watching my video. See you in my next video. Good luck in your exam. Admission for it. See you. Bye.